My name is Rob Romanowski. I'm the Director of Sales Ops at 3HTI, and every week we're going to be doing at least one webinar, whether it's going to be focusing on Creo or Windchill or another PTC solution. We want these webinars to be informative, helpful, where you, the viewer, take some value out of what we present and seeing things of how it can, help your business a bit and help your processes. And so anyway, today is a really popular topic, the Advanced Assembly Extension within Creo. So without further ado, I'm going to hand everything over to Paul Dye, who is a solutions consultant and applications engineer with PTC. Paul's going to take us through a presentation of the Advanced Assembly Extension, as well as a demo. If you have any questions, please put those into the question and answer box, and we'll try to answer those as we go along. We will definitely answer all questions by the end. Paul, take it away, my friend.
All right. And you can see my screen, hear me okay?
Yes, I can.
Awesome. Yeah, so happy to be on. And really, this is probably, I'd say, we talk about a lot of the different extensions that help in Creo. This is probably the most widely used extension in any portion of Creo. So happy to go through and explain a little bit more into it.
I would agree with that. That's one of the more popular extensions that our customers have.
Yeah, and
the most, actually.
It really depends. I mean, if you're looking to do any type of, I'd say, top-down design, this is, to me, an essential. It really enables that. And you can try to piece it together without something like advanced assembly, but really this is how, at least we in Creo, really deliver upon the promise of saying, hey, whenever you start to increase the complexity of the models that you're working with, and start to increase the part count, things of that nature, this is really what enables that. So I'll go through and explain a little bit more into it, what you're actually working with in advanced assembly, go through and show a demonstration, what it actually looks like to use advanced assembly, some of the different ways that we go through and set it up. But first and foremost, I always like to say, if you have any questions throughout, if there's anything that you want me to explain a little bit further into, feel free to drop those in the Q&A. We can definitely touch on that. If there's anything that I don't know, I have a pretty extensive resource network that I can reach out to and get really anything that you need answered as well. So without further ado, go ahead and jump into explaining a little bit more into advanced assembly. So start with really first and foremost, the challenges. This is really why we go through and want to lay out any of this, is to address some of the different challenges, especially whenever it comes to larger and more complex assemblies. There's oftentimes going to be multiple different people or teams working on designs, different portions of the design, and you want to be able to work together. You need to be able to share information effectively, keep everybody on the same page, and you need to be able to control that sharing process. The idea is you don't want two people, working on the same thing, going in opposite directions. And we see it all the time as your assemblies get larger and more complex. You see, I'd say that bottom up methodologies start to break down a little bit, just because there's too much referencing complexity, and some of the teams that you work with might even be outside of the company that you're working with. If you're integrating with partners or suppliers, oftentimes they need information. You need to make sure that their information is matching up with what you have, but at the same time, you might not want to share all the intellectual property that you have in your designs with those outside companies. So you need to be able to secure it, still transfer what you need. And traditional CAD, from what we've seen in the industry, is pretty limited whenever it comes to working with these types of designs. When you have 10, 15, 20 other people actually doing design work on a single type of model, you really need dedicated tools in order to assist you with that. And if you don't have a system in place, it's really slow, very tedious to plan, document, assemble things. Your models just aren't flexible. So what we really do in order to combat all these different challenges is give you tools in advanced assembly to help you work as you start to increase the complexity of the work as you're doing in an assembly sense, looking to speed up the time that it takes to get things together, working with outside teams, even down to manufacturing, be able to effectively manage everything throughout that process. And one of the biggest ideas around anything that we talk to in advanced assembly is your top-down design methodology. So instead of what you do from a bottom-up perspective, where you're kind of building all the pieces, almost putting it together like a Lego set, It's the other way around. We're planning the framework for how an assembly is going to go together, what it's going to look like. You're kind of laying that out from the start. And one of the main ways that we do this in advanced assembly is with skeleton models. This is laying out the framework for which areas of the assembly that we're working on. Certain designers are going to be able to work from within, being able to share and work with only the areas that you're concerned with. What we use a lot of times in here is a reference viewer. It's our tool for viewing and making our referencing a little bit more visual, and just how we go through and manage the different references, dependencies, and the parts, assemblies, how they feed into your sub-assemblies. And you want to have full control over the process. You're defining the scope for your model, where each part's connecting together, and making sure that you're sharing data effectively between the team. And that's another big part of the process here is more concurrent design. Because again, even something like top-down design, you're still going to have people all working at the same time. So the idea is that we want to be able to work together. So what you're seeing here in the image is how we would typically do this type of top-down design methodology while people are working together. You would say you have a lead integrator, a lead designer. They're essentially going to lay out the skeleton framework for, in this case, it might be like a knife design. And what they would do is take different pieces of that skeleton and share that geometry out to the different members of the team. So one member that's working with the handle might get certain pieces of that skeleton model. Then you have someone that's working on the actual knife, the switch mechanism, even out of the parts and suppliers. You're going to share out the geometry that they need. And what's really great about this is at some point later on down the road, if you're doing a design review and that lead integrator or designer wants to make some changes here, they might want to make maybe 3 slots for the fingers instead of 2, or decrease the curvature. Well, whenever they do that, it's not going to break everything that was shared out from there, right? Whenever you go through and make those changes to that initial skeleton, all those other members that have built their designs based off of that are able to be flexible. They're able to update in accordance with that as well. So data sharing using copy and publish geometry is how we do those types of things from our skeleton models. Another thing that we use a lot of times in this process is called inheritance models. This is giving you the ability to control whenever you make changes to certain parts or sub-assemblies, whether or not those changes actually get propagated up the line. So you can set up certain inheritance models where you have a main model, and then you have certain inheritance models for an analysis model where it's defeatured a little bit. You might have another model for manufacturing where it takes into account shrinkage, right? Some changes that you might make to those child parts or models, but still taking into account if you have a change to the design model, it gets pushed down to all of those different inheritance models. So that's something that we really enable through advanced assembly. Another big thing here is assembly configuration. We have tools such as interchange groups that we use for the things like fasteners, attachments, things that are always going to go on the same way, but you want to be able to enable different properties or different parameters for each of those. You can go through and get those set up. So that's something that we use a lot of times and really enables things like design to order. So you're starting with, say, a standard configuration that you have from within your assembly, but then you have 5 pieces of it that could be swapped around based on what you have from the customer's orders, or really from a new configuration that you want to get built out. So you have a standard configuration, then you can go through and make changes, interchange and swap out different components depending on what you need for that particular use case. Another part of this as well is process planning. So you can go through and build out the model, but whenever someone wants to go through and on the manufacturing side actually get this assembled, how does that model go together? Well, you're going to need graphics, you're going to need bills of materials, all the things for manufacturing to actually show how it's going to go together. We use ProProcess and inside of advanced assembly to do that. So it really helps you to get those documentation and process plans for how it's going to get assembled built out from what you've done in the assembly perspective. So another thing that gets enabled here with advanced assembly, and this all plays into our tools for visualization and performance management. If you have a big assembly, we have customers that work with 100, 1,000, 10,000 part assemblies, huge assemblies. That's a huge amount of data that your computer has to crunch. So we have tools to control that. If you only want to look at certain areas and have certain areas be more graphical representations where you don't have all that geometry built up and loaded every single time that you make changes, that's what you can do. So we have tools like our shrink wrapping design to take the time that it normally takes to load up a model. We're reducing that, putting it to memory. So those are all capabilities that we're working with here inside of advanced assembly. So a little bit might be outside of the scope of what you've normally done. So I can go through and show a little bit about what it looks like to work with those geometry sharing tools, so the skeleton models, and what it looks like to work in the different areas of the design here. So if you have any questions, again, feel free to drop those in. I can touch on really any of those that you might have. And possibly some of them might even get answered for what we go through and show in the demo as well. So I have our model that we're going to be working with here for the duration of the demonstration here. So this is a train model, and obviously anything remotely approaching the size of a train is going to be a big model. It's lots of pieces, a lot of work that's been done from start to finish. Even if you just break it down to a particular car or locomotive, it's a lot of geometry. So first and foremost, advanced assembly, or AAX, is about managing this model, keeping track of when you're working amongst your teams of who's controlling particular geometry, who's working in certain areas. And a lot of it revolves around the idea of our skeleton model. So a skeleton model can be different lines, arcs, curves, surfaces, anything that you want to use to set the overall control for the model. And the idea is, once you have that set up, we're going to take these different surfaces, curves, and I'm going to publish them and use them for particular uses. In this case, it might be for our structural components. That's one set of published geometry. And then from that same skeleton model, we can make another set of published geometry for another member of the team that might be working more so on the interior. So we can grab the surfaces over here, a couple other sets of curves. It's really whatever makes sense. Curves, lines, arcs, points, any references that you want to share downstream. So again, for something like this, we might want to get those windows and publish this out for our interior. So we have those components sort of fed down from my skeleton model to the different users. And we can go ahead and open up the structure here. So the idea is that once you do this, the different members of the team can all work from that same controlling geometry, but one member of the team can be working on the structural model, another team is going to be working on the interior. You're not getting in each other's way, and you're able to react to changes as well, because that skeleton that's coming from the top level is controlling the work and what we're actually basing our designs off of. So I can show a little bit about what it would actually look like to pull from. So maybe me as a designer, I'm working on some additional support hoops to help the structure here for our cart. I can just simply use the curve that we pulled in from the skeleton. In this case, I'm going to go ahead and use it to do a sweep of the shape, just to kind of show you what this would look like here. And really the idea is that from this point, we're really just going to be doing our standard CAD Creo work that we're used to, right? But while we're doing this, it's really controlling that, making it easy to make those connections to the rest of the assembly, to control them. And as you can see here, going through and making changes. So you can go ahead and take that and use it to define the features that we want to create from this point as well. I think it's looking pretty good. Go ahead and take that, and we can remove some of the material where it's going to connect in with the rest of the assembly here. It's looking a little bit better, and probably want to go through and pattern that along the length of the card. Go ahead and have that propagated throughout here. Again, all controlled by that master overall shape from the top level, helping us to really make these different changes and know where they need to go. All right, so I think that's looking pretty good. I got my new hoops, all the geometry. So what I can do now is go back and turn on the rest of the structure assembly. For a lot of these, I'm going to be working with lightweight representations. If you don't need to work with all of the part, or you just want to work with certain parts in particular, you can turn those off or on, change the visualizations, change the geometry that's being pulled in with that. And now I could be another designer here working on the interior. Maybe I need to build something on the wall, work with just a piece of this. In this case here, I've got an existing wall that I want to punch out where the window goes. And I need to know what's the size, what's going to be the shape of the window. Well, to do that, I can just pull in the geometry that we have from that skeleton model that we shared out using the published geometry. I'm going to go ahead and take that loop, and we'll make a form feature out of it. This is a big sheet metal piece. It's going to be punched out. So we can just go ahead and give it a little bit of thickness here. Quickly give it a taper here. And in my case, I'm just going to put out a little bit further because I know I'm going to trim it based off of another curve that I pulled in from that published geometry. So go ahead and give it a bit extra here. And then we can use that curve here to trim off what we need. So that outside curve is really controlling how far out this can go and making sure that it's not going to bump into any walls or anything of that nature. All right, so that's looking pretty good. We have some windows now so our passengers can actually see outside of the train. It's definitely a good step there. I'm going to go ahead and turn the other walls back on and regenerate the model. And we're good to go. So I can go ahead back to the top level train assembly here. And if we're working back on the top level, maybe we'll take this here and set some of the lower levels to a more simpler graphical representation without all the data being loaded up. Whatever we need to do there. And then as the third designer, I can be going through and working on the doors at the same time. So it's the same sort of thing. I have my skeleton model that we pulled inside of that door assembly. In this case, I also have a shrink wrap of the rest of the geometry. So I want to be working with the door, but I want to be able to see the rest of the pieces, but not necessarily having to load up that entire car assembly. So working with things like the shrink wrap of that existing floor structure is going to help us there. All right, so we can go ahead and copy in the geometry that we had from before. So I'm actually just making a change there to say, okay, whenever I want to make a certain edit to a piece of the design, what you're doing is saying, okay, if there's any updates made from that published geometry, I want to be aware of it. So instead of going through and simply just saying right now, you can have it as an automatic update like it was before, you have control over, okay, whenever something gets changed to how this was designed, does that automatically get pushed down the line? Do you have a manual update with that? Or do you have a notification or even no dependency? You have some control in that sense. I'll go through and explain a little bit more into that as we go along here. But what I would do from this point is just go through and make our changes, right? Let's go ahead and do some normal design work, use the surface feature, that quote that we copied in from the skeleton, and use it to make our door. Go ahead and give it some thickness. We'll cut out the windows. See how that looks. This is going to be another big drawn sheet metal part, so we'll probably go ahead and shell that out. Give it a certain thickness for this as well. And that's looking pretty good. All right, so we can go ahead and now have the base structure for the interior of the door. We can turn on the rest of this so we can kind of see where we're going with all of that. So now that I have my door structure, we're going to go ahead and keep it moving along. So again, we can see, just set it back to your master representation to see all the geometry once you've gone through and done the changes that you want. And that's really what advanced assembly is enabling for us. We're setting the different representations, copying the geometry from the top level, and using it to do more work at the assembly level, be more flexible, give you the ability to go through and make those changes even late into the design cycle of what we're doing here. Another tool that we use a lot of times in this process that really helps us out for this type of work is what we call a design exploration session. If this is something that you haven't seen before, it's something that comes right out of the base with Creo, something that really everyone that's doing any type of iterative design work should be using while you're doing this. And the idea is that we want to avoid the process of creating new save files every time that we try an iterative change through the process. What this is going to bring up whenever I start into one of these sessions is a checkpoint tree. And right now, when I'm in this session, all the changes that I'm making actually aren't going to be applied straight to the geometry just yet. It's almost like a white space where we're able to go through and make different changes, branch into different areas, and then only at the point where we're actually happy with the changes that we've made will we go ahead and accept it and have it applied to the file that we're working with. So this might be a little bit more of a risky change. Maybe we want to go through and make a change to that overall skeleton geometry that defines everything that we were pulling from. Maybe we need to increase that angle to pull it in just a little bit. Well, what is that going to do to everything else that I've done down the line, right? Whenever I go through and make changes there, everything can update because all the different features were defined from that skeleton model. Whenever we make a change to it, we want that all to be updated. And you can see that there's actually one thing that wasn't updated automatically. That was based off of the one that we changed to be a manual update with the notification. So we can go through and see exactly what was changed there. This is really useful if you want to have a little bit more control over that process of change. So what we can do first and foremost is look at this and show the differences. This pulls up the model and shows over here in the gray what it was like before and now what it looks like after the changes have been made. So from that point, you can go ahead and decide whether or not you really want to have that change go through, whether you want it to be affected. And through the design exploration session, we can go ahead and create a checkpoint to show where we were at right after we made that shell change. Right, and we can go ahead and keep working from there, right? We can go ahead into our passenger car. I'm gonna open up a cross section so we can see what's going on inside of here. And maybe I wanna make a change to something within this interior. And really, again, this just goes back to your normal Creo work. maybe I want to make a change to the armrest, whatever it might be. This design exploration session that we're working with inside of here is essentially going to be watching those changes and allowing you to say what you like, what you don't like, and then give you that design history as well that you manage through those checkpoints and the branches that you might do from that. And one thing you could also do is see the different changes that have happened from within here as well. You see things that were renamed or modified or reordered. It shows you that full history of what's actually been done with the design. And if you like where you're at, you want to be able to reference back to that, just go ahead and create a checkpoint right from within there as well. So again, these tools are really helping me if I'm doing more of this complex work later on down the design process. It helps you to see the different changes that you've made. Do you want to keep them? If you do, simply just put a checkpoint wherever you made the change. And the idea is you don't have to keep it, right? We're not doing a save as or making new names or new files. At any point, you could say, you know what, maybe that's not where I wanted to go. I'm going to go back over to a different checkpoint, whatever it might be. Even if you want to just get out of the session and not save any of the changes, that's perfectly fine as well. All right, so again, from there, we have our new shape, we have the new profile for the cart, again, all being controlled through advanced assembly. It's really allowing us to make changes later on down the process to our assemblies, allowing you to be a little bit more flexible and make sure that everyone from within the team is able to be benefiting from that flexibility as well. All right, so that covers most of what I wanted to go through and show for the advanced assembly extension. Again, there's a little bit more to it than if we've even gone into. There's some kind of low level capabilities that you're going to get as part of that process. But again, at the end of the day, it's really giving us a ton of value and giving a lot of companies that use Creo a ton of value as well. So first and foremost, what it's allowing different companies that we work with to do is reduce time to market. If you have everybody that's on the team working in more of a streamlined product development system, whenever you have changes happen, those get propagated much faster. It's a lot less iterative work and errors that get through that process as well. And because the errors are being removed, you're probably going to get things out at a better quality as well. You don't have things that get out to the shop floor, you put it together, just then to realize that it's not going to work. So same thing with supplier products, that if you are able to share enough information, you can make sure that you don't have those errors slip through the cracks. And putting those together, you're actually developing and working into new markets, right? If you're able to try new things more so, you're using things like design exploration to try more variations of the assemblies that you've created, just tie that in with the normal process that you work with and give you the ability to explore a little bit more as well. So overall, just looking to control that process and eliminate those errors at the end of the day. All right, so that covers everything that I wanted to go through and talk with. Again, if you have any questions, feel free to drop those in the Q&A. But with that, I can pass it back over to you, Rob.
Thanks, Paul. Nice job, buddy. Appreciate it. This advanced assembly extension is a huge time saver, especially when modeling assemblies with many parts or larger assemblies. And I know that that's a struggle for certain CAD systems. So if you're not using Creo, you should definitely have a conversation with us. We can give you some insight to what our customers are doing and how they've overcome some of their challenges in migrating to Creo from another CAD system and being able to utilize successfully a tool like the Advanced Assembly Extension. So this video is being recorded, and I'm going to have it uploaded onto our YouTube page, and we'll be emailing the link out to everybody either later today or by tomorrow morning first thing. So keep an eye out for that. And next on our webinar series, next Wednesday, we're going to have a webinar focusing on Windchill's NPM link for manufacturing. And then on the 28th, we're going to have a Creo webinar, Thursday the 28th, on generative design, which is both the NPM link and generative design are part of our sustainability series, because a lot of manufacturing companies are developing sustainability initiatives to help not only become more efficient in their processes, but also reduce waste, reduce scrap and rework. And these tools within our sustainability series help these companies meet their goals for sustainability in reducing costs and waste. And also with generative design, being able to think outside the box and allowing the extension within Creo to come up with ideas that you'd never even thought of. I mean, I spoke to a pretty prominent design engineer who works for Cummins, who basically said to me, you know, with this, what we just came up with generative design, he said, I've been modeling for 30 years in CAD. I never would have came up with this. So that's going to be a really cool webinar also. So hopefully we'll see you guys on there. Paul, thanks again. And if you have any questions or want to see a more detailed demo or get any additional information, just respond to the email that I sent you for the invitations for these webinars. If they come directly back to me. Or you can email us at info@3hti.com. Thanks, everyone. Have a great day.